Good morning, Ms. McClain here, and we are getting ready to do January 2025 exam, Part B2. And here we go. Exam, Part B2. And here we go. All right, so this is what the exam looks like. And as you can see, Part B2 will start at number 51. And you will be given the Part B2 answer booklet to write your answers on, and as well as the Earth Science reference table. I am using the Earth and Space Science reference table, the new Earth and Space Science, as I am the new Earth and Space Science teacher. And so this January 2025 exam is going to be based on the old Earth Science exam. So anyways, here we go. Question number 51. As you can see, the directions tell us that we're going to use the information that is given or provided in the next few pages to answer questions 51 to 65. It is always the best thing to read the directions. So we'll start right here with question 51's paragraph. It says, base your answers to question 51 through 53 on the passage below and your knowledge of Earth science. Evolution of stars. A star forms from a huge dust and gas cloud called a nebula. Gravitational forces causes the cloud to contract. As matter in the cloud draws closer together, temperature and pressure increases. Okay? Causing hydrogen to combine, forming helium in a nuclear process. The energy released by this process is eventually radiated into space in the form of electromagnetic energy, some of which can be seen by humans. A star about the size of our sun takes about 10 billion years to go through its life cycle. It begins with the formation of a main sequence star and then goes through a giant star stage. Finally, in its last or late stage of existence, it becomes a white dwarf. Stars much more massive than our sun undergoes explosions called supernovas. All right, so that was a lot of information that they gave us about stars. And since they gave us information about stars, the first thing I want to do is look at the Earth Science reference table and see which talk about the life cycle of stars. And we can see that that's on page 4 and 5. So I'm going to just go to page 4 and 5 just in case that I can use this as a reference. We know that the Earth Science table is just for reference purposes, and sometimes you may find the answer there, and sometimes you may not. All right, so the first question for number 51 says, identify the nuclear process that produces energy in stars. So since it's telling me to identify a process, I know that I probably won't need the Earth Science reference table. I have to actually know, how do stars form? Did they tell me about this process in the paragraph? They did, but they did not mention the name of it. So this is a Earth Science knowledge question that you must know. And if we know from our learning experience throughout the year, we would know that this is called nuclear fusion. Okay, so nuclear fusion would be our answer to number 51. And like I said, it's just a knowledge question, so you just need to know your Earth Science background. And as you can see, I'm going to write it in the book in here because sometimes we mess up on our answers. So if we have it in the book, that's okay. That can be where we can just place our answers, but then we put the actual correct answer in the booklet. All right, question number 52. Identify one star that was formerly a sun-sized star, but now it's in its late stage of existence. So what do they mean by a sun-sized star? They basically mean the size of our sun. What is our sun right now? If the paragraph told us that a star about the size of our sun takes about 10 billion years to go through its life cycle, and it begins with the formation of a main sequence, and then goes through the red giant stage. Later, and finally, in its existence, becomes a white dwarf. So if we go to our stars chart, we can see that the sun is currently a main sequence star, right? We see that right here. Right. So now if you come to your life cycle of star model and you follow what the life cycle of the sun will go through, as it told us, we know that it will become a white dwarf. All right, so I'm going to look on my Earth Science reference table, and I am going to look for a white dwarf star that will most likely go through the same life cycle as our sun. So I can either pick Procyon B or Sirius B. Either way, I will get this answer correct. Why? Because they both will go through the life cycle just like our sun and become a white dwarf at the end of their life. So I'm going to put down Procyon B. Of course, it's your choice which star you want to use, but you will get the answer correct, whichever one you choose. All right, so let's move on to number 53. Barnard's star and Betelgeuse are stars having similar color and surface temperature. Explain why Betelgeuse will most likely undergo a supernova, but Barnard's star will not. So they have the same temperature and they have the same surface color. All right, so here's Betelgeuse and it's red, and then Barnard's star, it's going to be, let's see, we have to locate Barnard's star really quickly. And here we are, Barnard's star. And it is between red and orange. Okay, so since Barnard's star is currently in the main sequence, I know that Barnard's star is most likely going to take the same life cycle as our sun and not become a supergiant star like Betelgeuse. It will most likely just become a red giant and then go straight to a blue giant and then to a white dwarf. So Betelgeuse is a supergiant and it's very luminous and it's a very old star. So if they want us to explain why Betelgeuse will most likely undergo a supernova, but Barnard's star will not, it's because Betelgeuse, so we can say that Betelgeuse, I should have wrote this in my book, but they don't give me enough room on this question to write in a book. So Betelgeuse is a supergiant star with a high mass and luminosity, while Barnard's star will take the same, I'm going to say it will take the same life cycle as our sun. Or you can say something in the nature of, it will take the same life cycle as our sun, or Barnard's star is currently a main sequence star. So main sequence stars in their lives as white dwarfs. Or Barnard's star is currently a very low mass star. So we know that Barnard's star will eventually become a white dwarf at the end of its life. All right. Okay. So next is number 54. And number 54 reads, base your answers to the question 54 to 60 to 56 on the passage below and your knowledge of earth science. The passage describes the formation of Albany pine bush. Approximately 6,000 acres near Albany, New York, is known as the Albany Pine Bush. Its history began about 15,000 years ago when 1 mile thick glacier melted at the end of the last ice age, forming a giant lake that was over 190 miles long. Scientists call this lake Glacial Lake Albany. The lake eventually drained, and the sandy deposits on the lake floor were blown into the sand dunes. The sandy dunes were gradually covered by plants. All right, so that's the paragraph. And the first question reads, identify the geologic period when Glacial Lake Albany was first formed. So since they said geologic period, I know that I have an Earth Science reference table that goes with geologic history, and that's going to be page 6 and 7 of the Earth Science reference table. All right, so the first thing that I should do is I should know that Glacial Lake Albany probably formed just a little bit later in time than something like a tectonic process. Okay, so the first thing I'm going to do is I'm going to go to the reference table and I'm just going to look for Albany Glacial Lake Formation. All right, and as you can see at the top of the Earth Science reference table, it says advance and retreat of last continental ice. So in the paragraph, they told us that it was the last ice age. So with that being said, since I know that it is the top section that took place very recently, approximately 50 million years ago or less, I'm going to go over to the other reference table page, and I am going to look at anywhere between the periods at the top, Quaternary, Neogene, Paleogene, and I am going to see which one had the end of the ice age. And as you can see right at the top, it says end of ice ages. So this took place during the Quaternary period. All right, so I'm going to go ahead and I'm going to write Quaternary on my answer sheet. And yes, I might be a teacher, but let's see, how do you spell that correctly? Quatern. Good morning. All right, number 54. Identify the entire range of sand size covering the lake floor when Glacial Lake Albany drained. So I do apologize about that, but I'm going to skip number 55 because this is an old Earth Science reference table question, and I just don't have one in front of me at the moment. But if you were to do this question, you would use page 6 of the old Earth Science reference table, and you would go to the sand size particle, and you would get the size of the sand particles. Okay, number 56. All right, so we are currently on number 57 to 59, and it says, base your answers to questions 57 to 59 on the graph below and your knowledge of Earth Science. The graph shows the change in height of tides at the coastal locations for 2 days. All right, so this is our ocean tides, and we know that they are cyclic events. So if we can see on the diagram that our cyclic events pretty much occurs approximately every 6 hours or so. So question number 57 says determine the height of the tide at 5 p.m. on Saturday. So I'm going to go straight to 5 p.m., which of course will be in the middle of 4 to 6 p.m. And if I draw myself a little dotted line for a reference going straight across, I can get a more accurate answer. So as you can see, it does not land exactly on 2. So if you want to put a range to be on the safe side and say something about 8.1 miles to 2 miles, that's perfectly fine. All right, so that's how you answer that one. And the next question says, predict the time of the next high tide on Monday. Include AM or PM in your answer. Okay, so I see that the last high tide, it started to come up about 6 p.m. It was as high as about 7 to 8 p.m. And then about 9 p.m. is when it reached its peak. All right, so if I want to know when the next high tide is going to occur, then I'm going to base that off of a 6-hour difference. I'm sorry, not a 6-hour difference, a 12-hour difference from when the last high tide occurred. So if the last high tide occurred at 9 p.m., then my next high tide should be anywhere between 9 a.m. and 10 a.m. All right, and then we'll answer the last question on this page. Identify the force that causes tides. That force will be the gravitational force, or the force of gravity. Okay, now anytime you see the force, that should automatically be something that comes to your head is the gravitational force. They love to ask you about the force, and it does not apply just to our ocean tides. All right, next page. Okay, number 65 reads, base your answers to questions 60 and 61 on the diagram below and your knowledge of Earth science. The diagram represents the effect that cloud thickness has on incoming solar radiation reaching Earth and outgoing radiation. Thickness of arrows represents the relative amount of radiation. So in the diagram, they're showing you how much energy is going to come from the sun, come down to space, how much is going to be able to reach space, how much will be reflected back into space, or how much will be coming and being absorbed by the surfaces. Okay, let's read the first question. It says, describe how the thickness of cloud cover at a particular location affects the relative amount of solar radiation reaching Earth space. So they're talking about the thickness of the cloud and how this affects how much solar radiation we receive here on the surface. So if I am thicker, do you think that I will have more incoming solar radiation or less incoming solar radiation? Well, according to the diagram, it's showing us that I might have just a little less incoming solar radiation going to the surface, but more radiation going back out being reflected. All right, so if I have any knowledge about Earth science, I should know that the thicker that the clouds are, the less solar radiation that I will receive. All right, so let's write that in the space. All right. So now number 61 reads, state the name of the temperature zone at Earth's atmosphere where most clouds form. So first thing I read was temperature zone. What is a temperature zone? I'm going to guess where temperatures take place. And then they told me that this is in Earth's atmosphere. So first thing I'm going to do is look at my Earth science reference table. I'm going to see where the atmosphere is talked about, and we see on page 19 they give us a cross-section model of the Earth's atmosphere. So let's turn to page 19. And if you don't know by just based off the knowledge of Earth science where clouds take place, you can come here and you can look at the cross-section and you will be able to see that in the troposphere is where my clouds are. So this is where my clouds will take place. But as soon as I reach the tropopause is when my clouds will stop forming. So anything past the tropopause, so the stratosphere, mesosphere, or the exosphere, we will not find any clouds. But in the troposphere is where we will find clouds, because that is where most of our weather on Earth takes place. All right, so our temperature zone on the Earth's atmosphere will be the troposphere. All right, number 62. Base your answers to questions 62 to 65 on the diagram in your answer booklet and on your knowledge of Earth science. The diagram represents a view of Earth as seen from space on the first day of a certain season. Some latitudes have been labeled. All right, let's go to the answer booklet. Let's look at that diagram. Okay, so they want me to base my answers on here, and 62 reads, on the diagram in your answer booklet, shade the portion of Earth that represents nighttime. So if I come here and I say, okay, well, how do I know which section will represent nighttime? Well, the sun's rays will give it away, okay? So if the sun's rays is facing the right side, and then there is no sun's rays on the opposite side, then I know that nighttime is most likely going to take place on this side of the Earth. All right, so simple. Next, identify the season that is beginning in the northern hemisphere when Earth is in this position. So they have Earth in this position where the tilted axis, as you can see, looks like a little bit more than 23.5 degrees, but that's not really a concern right now. The concern is they want us to identify the season. So is it summer, spring, winter, or fall in the northern hemisphere? So I know that the northern hemisphere is anything above the equator. So since the sun's rays is hitting above the equator, spot on, as I can see if I draw a dotted line, and I can see that it's taking place right at the Tropic of Cancer. So what does the Tropic of Cancer represent? It represents the summer solstice. And the summer solstice is, I know from my knowledge, is the time where the sun is highest in the sky, where my sun's rays is direct, spot on. So this is going to be the longest day of the year. All right. So with that being said, what is represented? Which season is getting ready to take place? That would be summer. And currently, if they ask you about the southern hemisphere, they will be experiencing winter. All right. So I'm just on line 63. I'm going to write summer. All right. Let's read 64. State the number of daylight hours that an observer at the equator would experience on this day. So the number of daylight hours. How many hours of daylight would I have? The normal hours of daylight would be anywhere from 6 to 8 hours a day. But on this day, on June summer solstice, if the sun is high in the sky, if it is the longest day of the year, then I know that I'm going to have about 12 hours of daylight, okay? And that is due to the sun's rays being spot on and high in the sky on this particular day. All right. 65. Compared to the current summer and winter temperatures in New York State, describe how New York State's summer and winter temperatures would change if Earth's rotational axis were tilted at 33.5 degrees instead of 23.5 degrees. So compared to the current winter and summer in New York, so we know that at 23.5 degrees is when we receive our different seasons and our variations in temperatures. So if I change the latitude to a higher angle, do I think that I'm going to have more heat, more direct sun's rays, or less direct sun's rays? Of course, I will have more of the direct sun's rays because I am at a higher latitude. That means my tilt is at a higher angle and I am receiving more of the sun's rays. So how would this affect the summer? So our summer temperatures, of course, will be warmer. So I can put that the summer temperatures will increase or become warmer. And then my winter temperatures will do the opposite. They will decrease or become cooler. All right, so that is it for part 2B of the Earth and Earth Science January 2025 exam. If you have any questions, you can always reach out to me. I am Juanita McClain, and I have an Instagram page at Science with McClain that you can follow me on and send me messages there. Take care.